Section 3.2, we are going to solve systems of equations using the substitution method. Not every system can be solved easily by graphing, especially if the intersection point is not on whole numbers. Also, if you are not super accurate with making your graphs or drawing your lines, it can also be challenging to tell where those lines are supposed to intersect. Substitution allows you to find exact solutions algebraically. So we won't have to graph anything, we're just going to use our algebra skills. To solve by substitution, change one of the equations to get a variable by itself. So you pick one equation and one variable to get by itself. Next, substitute or plug in that expression for the variable in the opposite given equation. Now that kind of sounds confusing in words, but we'll see what they mean by that in a moment. The next step is going to be solved for whichever variable is left. So after the second step, you should only have one variable left in your equation. You're going to solve for it. Finally, use the solution obtained to find the value of the other variable by using substitution again. So the substitution method sometimes feels like we're going in circles. You solve one equation, you use it, you plug it into the other equation, you solve that equation, take that solution, plug it back into the other one again. So we just keep kind of circling around until we get our answer. On example 1, we have two equations here, a system of equations denoted by our brace on the side. 3x plus 2y equals negative 17 and x equals 3y plus 9. So if we go to those steps that we just went through, the first step says to do what? Change an equation to get a variable by itself. Do we need to change one of these equations to get a variable by itself? No, they made it easy on us. We already have x by itself in the second equation. So that first step was done for us this time. How nice. All right, so then we are going to take the expression that it's equal to and substitute it into the other equation. So what that means is if x is by itself, I'm going to be replacing x in the other equation. So what I like to do is rewrite the top equation, leaving a blank for the variable that I'm replacing. Since x was by itself, I'm going to substitute into x in the other equation. Now what do you think is going to go in this blank? 3y plus 9. That whole expression gets plopped in for x. 3y plus 9. Now that we've done the first and second step, we just have one variable left. The only variable in this equation that I wrote is y. So that means I can solve it. This is like way back to Algebra 1 type skills. What's the first thing I'm going to do? Distribute. When I distribute, I get 9y plus 27. Still have that plus 2y. And it still equals negative 17. My next step. Next, we combine like terms. If I combine 9y and 2y, what do I get? 11y. So we have 11y plus 27 equals negative 17. I think somebody jumped ahead. What do we do next? Subtract 27 on both sides. 11y equals negative 44, and then
y equals 4.
Divide by 11, y equals negative 4, which I'm going to rewrite up at the top. All right, we are not done until we have x and y. Our answers on all of these are going to be an ordered pair. Even though we're not graphing, my answer needs to be an ordered pair, x comma y inside parentheses. That's how I should see your answers on all system of equation problems. All of them, all of them, all of them. So now we know that y equals -4. So that's what that third step was. Take this, plug it back in to one of the y's. It's going to be easier to use it in the second equation. And now figure out what x is. So x equals 3 times, plug in -4 for y plus 9. So now I'm taking the second equation from the beginning. I'm plugging in what I figured out y to be, and now I can solve for x. Okay, so we have x equals -12 plus 9. X equals -3. So great, I have x, I have y. My answer should be written as an ordered pair. So -3, comma, -4. That is the answer. What's nice about example 2? One of its variables is already by itself. That makes our life so much easier. Y is already by itself. So I'm going to go to the other equation and rewrite it, leaving a space to plug in for y. Oop, not what I want to write in. Here we go. 4x plus 2, parentheses, because I'm going to plug something in there, equals 7. What goes into those parentheses? 5x. So we're not using y anymore, we're replacing it with what y equals. What do I do to solve? Sort of. Really, it's just multiplying, right? To distribute usually implies we're multiplying to multiple things. 2 times 5x? 10x equals 7. 4 plus 10? 14x. To get x by itself? Divide by 14. Now on problems like this, don't get excited. I see a lot of students get this far and say x equals 2 because they get real excited about the 7 and the 14. Okay? Don't do it. Don't do it. It's not 2. What is it? 1/2 or 0.5. I like fractions. A decimal is acceptable. Okay, so we figured out what x is. So if we are writing our answer already, we already know the x part is 1/2. Okay, I'm going to put my answer up in the corner. You can put it wherever makes sense to you. But we only have half of our answer. How are we going to find the other half?
Plug in x.
Plug it in. Okay, substitution is all about plugging stuff in and plugging stuff back in and plugging it in again. So you can technically use either equation, but which one's going to be easier? The bottom one. The y equals 5x. If we're trying to figure out what y is, and y is already by itself, that is going to be the one we want to use. So y equals 5 times 1/2. What is 5 times 1/2? Okay, you can say 2.5 because I like fractions. I like 5/2, but 2.5 is not wrong. So 2.5 would be acceptable. So our answer is the point 1/2 comma 5/2, which if we were to have had to have graphed those lines and found that intersection point, that would have been really tricky. Unless our graph was ginormous and sectioned off into halves. Usually they are not. All right, we get to choose which equation we want to work with and which variable we get by itself. Okay, I like using the second one because there's a 1 in front of both the x and the y. That means our lives will be a little bit easier. So we're going to use the second equation, and which variable do we want to get by itself? y. It does not really matter. You get to choose which equation and which variable. So if I want to get y by itself, what do I need to do to both sides? Subtract the x. So y equals negative x minus 12. If you had negative 12 minus x, that works too. Okay, so now we kind of forget about this equation. We just kind of block it out from our memory. Now we're using this new one that we found, where y is by itself. So now we're at the step where we rewrite the other equation, that top one, 2x minus 3. We put a big blank for the y, because the y is what we got by itself, equals 6. What's going in that blank? The negative x minus 12. Okay, negative x minus 12 goes in the blank. We just have to be careful on our next step, because we're not just distributing a 3, we need to treat it like a negative 3. So when you distribute here, treat it like a negative 3. So plus 3x and then plus 36. Very good. Okay, we have to treat that like a negative 3 or it's not going to come out right. Alright, 2x plus 3x. What do I do to get x by itself? Subtract 36. So we have 5x equals negative 30. Then what? Divide by 5. X equals negative 6. So I start writing my solution. Negative 6 gets in for x. I still have to figure out what my y is. When it comes time to figure out your y, you can go to either of the original equations or you can use that one that you rewrote. Which would you like to use? The one we rewrote. Now, the only thing I'll caution you on is that if you messed up rewriting it, then you messed the whole thing up, right? So it's fine to use the one that we rewrite as long as we are confident that we did it correctly. But if you didn't rewrite it correctly, then your x might not be right anyway. So, all right. The other thing we have to be careful with is that this is a negative x, and x is negative. We can't just drop off signs. So, a negative negative really means it's back to being positive. What is 6 minus 12? Negative 6. So on this one, x and y, we're the same. How could we check ourselves? Plug it back in. So go back to an original problem and plug stuff in. Now here, if we take 2 times negative 6, what's that? Negative 12. So negative 12 minus, what's 3 times negative 6? Negative 18. Subtracting a negative really means we're adding. So negative 12 plus 18 is 6. So much suspense there. So we did get it correct, okay? We would normally want to check it in both equations, but yeah. Yes, we got it right. Okay, so before we started this problem, we said it would probably be best to get y by itself in the top equation, which is fine. How would we do that? What's the easiest way to do that?
We would subtract the 3x.
There's an easier way to do it.
Zero.
Since this side's 0, we could just move the y over. If we add y to both sides, that would give us 3x equals y. Now y's by itself. Okay, it's fine if you subtract the 3x from both sides, but then you also then still have to switch the signs by dividing off the -1. If you did it that way, that's okay. You get the same thing, right? Our goal was to get y by itself, and that's what we did. All right, once we have y by itself, we can kind of ignore all of that. We're focused here. Okay. It's actually a highlighter, but on this screen it looks green.
That's a nasty color.
Yep. All right. Oop. Switch back. So 4x plus 3, we'll leave a blank for y, equals 26. What goes in that blank?
3x.
The 3x. So in the steps for how to do this, when it says plug the expression in, that's what it means. 3x is our expression in this case. Okay. 4x plus 3 times 3, 9x. Combine like terms.
13x equals 26.
And then
X divided by 3. We get X.
we are all over this. Divide by 13, we get x equals 2.
Yes, it does.
So we start writing our answer. We've got 2, comma. How are we going to find y?
In the X.
Plug in the x. So
Equals X times 2.
So y equals
3
6.
6.
6.
Y equals 6.
I am so glad you guys are just as excited about these as I am.
I'm just running.
So I'm very
All right, so when we plug x in, we get y equals 6. Do we have questions about example 4?
No, it's just 2 6.
Do we have homework? Are we done now?
Are you doing 2, 5, and 6?
5 and 6.
We have 5 and 6 to do still, guys.
Why did you write it down?
All right, so we have agreed to get y by itself in the bottom equation. Unfortunately, it's not quite as easy as the last one, but it's still not so bad. What do we do to get y by itself?
Subtract 2X.
Okay, subtract 2x. That leaves us with negative y. Don't drop that minus sign. Negative y equals negative 2x plus 7. If you put 7 minus 2x, that's fine. It'll come out the same. But now, we don't want negative y, we just want y. So what happens? Divide by negative 1. So really what happens is all the signs flip the whole way through. If y becomes positive, the 2x becomes positive, and the 7 becomes negative or changes to a minus 7. Now that we've done all of that, we can really ignore all of that, right? And we're just focused on that top equation that we haven't touched yet and our new equation we just rearranged. So we are going to rewrite the top equation, leaving a blank for which variable? Leaving a blank for y. What goes in the blank? The 2x minus 7. What do we need to do next? Distribute 4x plus 6x minus 21 equals 4. Now what? Combine like terms. 4x plus 6x is 10x. Still minus 21 equals 4.
21 to both sides.
Add 21 to both sides.
10x
10x equals
equals 25.
25.
Divide both sides by 10.
Okay.
X equals 2.5. Well, 2.
It's fine. Fractions or in decimals, either one's fine. Like on this one, I understand that a decimal might be more apparent because we just move the decimal point over when we divide by 10. So I'll be okay with that. 2.5. So x was 2.5. How are we then going to find y?
Plug that in. Y equals 2.
All right, y equals 2 times 2.5 minus 7. 2 times 2.5 is 5. 5 minus 7.
Negative 2. So y equals negative 2.
All right, so y equals negative 2.
Sounds cool.
And we have our answer. Questions, concerns? Confusion?
Yeah, with our homework and other worksheet.
Alright, let's aim to get x by itself in the top equation. It's all gonna be okay, I promise. If we get x by itself, what do we need to do first? Add 2y to both sides. So we get 3x equals 2y plus 5. And then what are we going to do? Divide everything by 3. So x equals 2/3 y plus 5/3. Now I understand this looks ugly right now, but let's not freak out too much just yet, okay?
Hopefully they didn't go instead.
So now we need to use that bottom equation that we haven't touched yet, and we are going to put a big blank for which variable? The x. So we put a big blank for x. We rewrite the whole thing. And what are we putting in that big blank?
Oh, wait.
2/3 y plus 5/3. Now, if you have a calculator, you'll notice what happens when we multiply or distribute -6 in is that those fractions are going to go away.
Negative 4y.
-4y
10.
minus 10, a negative times a positive makes it negative, plus 4y equals 7. 7 didn't change. Now, are we all okay with getting to this point? So don't let little fractions like that freak you out because they went away just as fast as we found them, right? It's all okay. All right. Now what happens?
Y's cancel out.
Yeah, we go to combine like terms and they just disappear. So what are we left with?
Negative 10 equals 7.
So this equals no solution.
Negative 10 equals 7. Very good. Negative 10 does not equal 7. So therefore, there's no solution.
Wait, why did you get x by itself instead of y?
Because we felt like it.
Oh, so you can do either way.
Yeah. We get to choose which variable we get by itself. So I felt like doing x on that one. That's what we did.